Geometry 1.1, Points, Lines, and Planes. This is an extremely important lesson where we will learn all kinds of vocabulary and notation that we will use all year long. In order to talk about points, lines, and planes, we first need to talk about dimension. So when we talk about one dimension, we have lines. A line is the distance between any 2 points. Every time we measure the distance between two things, we're using one dimension. So then if we look at two-dimensional objects, if you look at the original Mario Brothers video game, in this game you can tell how thick Mario is, but you can't see how wide he is. Mario only runs and jumps, but he never turns to the side, so you can't see how wide he is. That's because the game was created in 2 dimensions. So here is a picture of that. So you can just see the profile side of him. He won't ever turn and face you. But then your generation got Nintendo 64 and all the other Nintendo games. On these systems, you could see Mario move in all directions. We could see that he is wide, he is short, and he has a big belly. That's because he is in 3 dimensions. He has a height, a width, and a thickness or a length. And so this is the picture of Mario in 3 dimensions. You can see all sides of him. You can see the front, you can see the left, the right, the back. You can see all 3 sides. So in geometry, we have some words such as point, line, and plane that are considered undefined terms. However, we need to be able to talk about them, so we have a general agreement about what each word means. We're going to start with a point. A point has no dimension. This means you can't see points. Right? Good thing to know about a point, this is a location. But it is a location that has no size. So there is no size. So no size, and a point cannot be measured. So there are points all around you. There's a point in the floor because it's just a location. So there's a location all over the floor. There's thousands of locations in the air, in the ceiling, on the walls. However, if we're going to talk about it in geometry, we need to be able to see something, okay, that we can reference. So we draw a dot for a point, and then we name it by a capital letter. So this would be considered point A. The next definition, a line extends in 1 dimension. It's represented by a straight line with 2 arrowheads. So I could draw a straight line, arrow, arrow. And let's say I have point A and point B here. To name that, I use the 2 points, A and B. And then the notation, I draw a line with 2 arrows on the top of it. However, I could also name this line as line BA. Order does not matter when I'm naming a line. If I had a line that didn't have any points on it, and here it says a lowercase script letter, that is just cursive, so maybe it has an L out to the side. To name that, I would have to write out line and then L. Next, we have a plane. A plane extends in 2 dimensions. It is usually represented by a shape that looks like a tabletop or wall. So we might draw it like this. You have to imagine, though, that that plane extends without end. So even though when I draw it, it appears to have edges, we need to realize that it continues to go on forever. We name these by 3 non-collinear points. So let's just say I have point A, point B, and point C. To name that, I would write out the word plane and then call it ABC. Again, order does not matter, so I could also call that plane BAC. Lots of different possible correct answers there. Next, we have a line segment. This is a set of points and that has a specific length, which means we can measure it. It does not extend indefinitely. It has no thickness or width, and it's represented by a straight line with no arrows. So this could be an example of segment AB. To name it, again, I use the points AB, and then the notation is just a bar on top of it. Again, just like a line, order doesn't matter, or I could name that as segment BA, and that's how we would say it. The notation on top, segment, and then the 2 points, BA. Next, we have what is called a ray. A ray is a set of points and extends in one dimension in only one direction. It has no thickness or width, and it's represented by a straight line with an arrow. Okay, so if I have this point, arrow here, and let's say this is F and this is G. Order matters on a ray. We always write from left to right. We start with the point that does not have the arrow, so I would name this ray FG with my arrow pointing always to the right. We wanted to add another definition here, opposite rays. So opposite rays are two rays with a common endpoint, and we're going to talk about endpoint. So usually endpoint, people think that's at the end, but here this is really a starting point. The endpoint is the one that does not have the arrow. It's where it starts. Okay, so two rays with a common endpoint and travel in opposite directions. And it must be exact opposite directions. So the opposite of up is down. The opposite of left is right. The opposite of up is not left. So let's say I had a line and I had it labeled A, B, and C. Opposite rays, they both start at B. That's their common endpoint. So I would say ray BA and ray BC are opposites. They have to have the same endpoint. Next, we want to talk about collinear points. Linear means line, co means together. So collinear points are points that lie on the same line. Then we want to add non-collinear points. These are these are points not on the same line. What's very important, we want to add here, any 2 points are always collinear. So one thing in geometry, just because it's not drawn doesn't mean it doesn't exist. So if I have any 2 points, I can make a line. So if I have an example and it asks me, are points A and C collinear? I don't even have to look at the picture because it's only 2 points. I automatically know, yes, I can draw a line between them. And we have coplanar points. These are points that lie on the same plane. We also have non-coplanar points, which again would be points not in the same plane. And then we want to take note that 3 non-collinear points always make a plane. Therefore, 3 non-collinear points would be coplanar. Again, it may not be drawn, but we need to know that it exists. So now we have some examples, and these examples are like the homework problems. So the first one, it gives us this picture, and it says use the figure to name each of the following. Name a line. I see line AB is drawn. So my notation, I have AB, and then I draw the line symbol above it. Or I could have also said line BA because order does not matter. Points, I have 4 points, A, B, C, and D. I need to put the notation, the dot A, so that's point A, point B, point C, and point D. Collinear points, these are points on the same line, so I could say point A and point B. However, I could also say point A, point D, because I could draw a line between those 2 points. So this is an example where I could have lots of possible right answers, not just one. Non-collinear points, I need 3 of them. So I could say point A, point B, and point C, because there's no way I could draw a straight line through those 3 points. I could have said point D, point A, and point C. So another one where there's lots of possible right answers. Next example, use the figure to name the following. So this is the picture that they give me. They want a line segment. The 2 points I have are K and L with the bar above it. So that's segment KL, or I could switch the order and say segment LK. My only 2 points here are point K and point L. Next picture, name a plane. I write out the word plane. I need 3 points that are not on the same line. Inside here I have ST and O. I could say plane STO, but I could also name that plane OTS, plane TOS. The order of those 3 points does not matter as long as they are not on the same line. The ray, I only have 1 ray here. Order matters. I have to start with the one that doesn't have the arrow, so I, R, with the ray symbol above it. Points, I have point S, point O, point T, point R, point I. Coplanar points, I need any 3 points that are not on the same line. So I could have point S, point O, and point T are coplanar. Non-coplanar points, okay. So I could have point S and point R. They are not coplanar. They are not in the same plane. 2 or more geometric figures intersect if they have 1 or more points in common. The intersection of the figures is the set of points that they will have in common. We have some postulates. A postulate is simply something that we cannot prove, but we accept to be true. We've already talked about this first postulate. Through any 2 points, there's exactly 1 line. The next postulate tells me if 2 distinct lines intersect, they intersect in exactly 1 point. So if I draw 2 lines crossing each other, where they intersect is 1 point. Postulate 1-3, if 2 distinct planes intersect, they intersect in exactly 1 line. So I'll come down here and draw that picture. So here's my first plane. My second plane, these dotted lines are showing that it's back behind that. They touch each other there and there. Those 2 points give me a line. I know that can be kind of hard to see, so let's think real world. So look in the room that you're in. The ceiling is a plane, the floor is a plane, the walls are planes. So look to where the ceiling and one wall intersect. Okay? Where do they have in common? A line all the way against that edge. The next postulate we've already talked about. Through any 3 non-collinear points, there's exactly 1 plane. All of these next examples, these are what your homework is going to be like. So we're going to give you pictures and ask you to identify certain things from those pictures. So this first picture, this is what it gives to me. This is named the intersection of line QZ. So QZ and segment WU. Where they intersect is at point T. Notation, remember, is important. So point T, or write out point T. But if you just wrote T, it would be wrong because the notation is not there. Same picture, now name the intersection of plane pi, so that's the plane drawn, and line DB. Here we need to note that the dotted line shows that the line, okay, is not in the plane. It's below the plane in this case. So this is an easy one to think about. If you take a sheet of paper and a pencil, and you put your pencil in the middle of that paper and poke a hole in it, the eraser is not in the plane, so like that would be this. This would be like the eraser of our pencil. The lead of the pencil would be like this, underneath the paper. Okay, that is not in the plane. So where they intersect is just that point right here where the pencil is touching your paper, which is point S. The next picture, name 2 opposite rays at point T. So I look at point T. I notice that if I go T to W, there's no arrow, so that is not a ray. So T to Q has an arrow. So TQ with my arrow pointing that way. And then directly opposite, again starting at T to Z. So ray TZ. That is my only correct answer for 2 opposite rays that start at point T. Same picture, what is another name for plain pie? I write out the word plain. I need 3 points in here. Remember, this is not in there and this is not in there. 3 points that are not on the same line. So Q, S, and U. So plain Q, S, U. The order doesn't matter. I could have said SUQ, USQ, or I could pick 3 other points. Plain Q, T, W. Lots of possible right answers there. Now we have a different picture. We have 2 planes that are intersecting. Name the intersection of plane pi and plane t. So again, remember that when 2 planes intersect, they touch on a line. So we go to the back and the front. That line is where those 2 planes intersect. So this would be line SB, or order doesn't matter. I can change it and say line B to S. Same picture. Now it asks, what is another name for plane pi? So again, I need to write out the word plane and pick 3 points in here not on the same line. So I could pick L, M, and C. L, M, C. I could say G, L, M, C, G, L. Name the intersection of line MG. So line MG and line BS, where they cross. Hello? Hello?
Did I wake you up?
No, I'm videotaping the lesson. So
Oh, okay. I'll go quick.
it's all right.
I'll go quick, Julie. The CDC came out today and admitted officially on their site that 94% of all COVID cases had underlying conditions and stuff. And basically, only 9,200 and some were actually COVID deaths.
Wow, they actually admitted it.
Get this information. You need the information is there. This is where they admitted it today.
Good.
So get to the freaking school. You gotta drop a letter in there. Whoever's in charge, go, you guys need to wake up. Everybody's lives up by listening to the lying. See, this is what they do. They lie. And when they get it going in the direction they want. But they so go to InfoWars. You guys need to watch InfoWars. These guys do the homework. They're like to watch judicial watchdogs that literally are out doing their homework.
Okay.
And pressing charges against like big players. From this point, do InfoWars. Whenever you guys get a chance, don't watch anything else. Punch it up and listening to InfoWars.
Sounds good. Okay, so name the intersection of line M to G and B to S. They at that point, so point C. Same picture. So now name a point that is collinear with M and C. That means on the same line. My only option is point G. Point G. Now we're going to look at a new picture. So here I have 2 planes. Notice that these 2 planes don't intersect. Planes don't always have to intersect. So remember we said that in the room you're in, the ceiling is a plane, the floor is a plane, the walls are a plane. Your ceiling and your floor don't touch each other. So that's a picture of this. Okay? Or you could imagine 2 sheets of paper with a pencil connecting the 2, going through both of them, but the papers don't touch each other. So name the intersection of plane pi, that's this plane down here, and line LC. So right there is where my pencil will be going through that. So that is point C. Next one, same picture, name the intersection of plane T. So that's this plane up here and line LC. That is at that point, point L. Same picture, name a point that is coplanar with H and L. So here's H and L, so I need another point that is not on that line. So here I could say point P. Name the opposite ray of CB. I only have one choice. It has to start at C. go the direct opposite from B, which is J. So CJ with a ray symbol. All right, so now we're going to get where we draw and label for each relationship. Anytime that they ask you to draw, you want to go ahead and read everything first and then look what order do I need to draw these things in. So plane pi contains this line and a point. Plane T contains a line and a point. These two lines intersect at this point. The intersection of plane pi and plane T is line. So this is where I'm going to start because I need two planes that intersect. So here is my first plane. I'm going to label that pi. My next one, I'm going to come straight down. Dotted line to show that's going back behind. And this is going to be plane T. They intersect the back and the front, and then I draw a line through that. And they told me that that line is line LU. It doesn't matter which point I call L or which one I call U. So I'm going to say that is L and that is U. So we have now done that. So now I come back up here. Plane pi contains line AB. I just need to draw a line and label it A and B in that plane. And then it says has point L. I already have point L in that plane, so we've taken care of all of that. Now the next plane tells me has point EF, or sorry, line EF, but down here it tells me that those two lines intersect. So I need to draw that line in this plane that crosses through line AB at point H. So I'm going to label that H. Somewhere up here I can put E, and somewhere down here I can put F. My last thing is this point S. Point S can be anywhere in that plane, so I could come down here and say point S. Next one, okay? Plane ABS contains lines AB, CD, and AK. Notice I only have the one plane, so I can go ahead and draw my plane. Line AB and CD, I see, have to intersect. So I'm going to say this is A, and this is B. CD, okay, intersects this one, so this is C, and this is D. They intersect at point G. So I've done that. CD, that line I just drew, and AK intersect at point S. AB and AK intersect at point A. So I know it has to go through here. So line AK. So this is going to be K. CD and AK intersect at point S, so that would be point S. That takes care of everything in that picture. We have those two intersecting point S, those two intersecting point A, those three lines in that plane. Our last picture, plane pi and plane T do not intersect, so that's like our ceiling and our floor. I'm going to label this one pi and this one T, so they don't intersect. Plane E, so I have another plane that intersects both of these. So I'm going to draw another plane here. Dotted line to show it's behind that. Dotted line back behind that. And this is plane E. It intersects pi at this line. And they told me that line is BC. B and C. It intersects this plane, this line, which they told me is line E and R. So that will get you today's assignment. All of your examples on today's assignment are like these, where I give you a picture and ask you questions, and then there's a little algebra review. That is 1.1, points, lines, and planes.